Hi friends, welcome to follow up. Let's have a look at problem 1081, smallest subsequence of distinct characters. In this video, we're going to explain how could we use data structure like dictionary and stack to solve this problem. So here we are given a string s. We want to return the lexicographically smallest subsequence of s that contains all the distinct characters of s exactly once. So that's the problem statement. So here we know that the length of this string is bounded above by 1000, and s consists of lowercase English letters. The second constraint basically indicates that so the result is at most 26 in length, right? So here let's analyze this problem. So we want to explain how to translate our intuition into code. So here the strategy will be using data structure to solve problem, right? So here the data structure I'm going to use the abstract data type. So we're going to dictionary and the stack. So here let's look at example 1. So we have an s which is BC ABC, right? So as a human being or person, so we see that the smallest lexically smallest subsequence we are going to have will be ABC in the result, because A appears once, so we should have A, and B appears twice, we should have B in the result, and C also appears twice. So here this one main point we want to notice. So here, as a program or some robot, so if we look at this string s, if we scan it, so we first see character B, right? So we know B will appear later, right? Then we also see C, right? And then we will see A, right? So because C is comes before A comes before both C and B. So here actually we can delete this C. The reason we can delete this occurrence of C is that C will appear later, right? Similarly for B, we can also delete B because B appears before A in the original string, but it also appears later. So in this case, we are going to have A, and then we can add B. But now B is comes after A in the dictionary order, in the lexicographical order, right? So we have C also comes after B, and also C does not appear later, right? So in this case, so we're going to get ABC. So that's the main point, right? So if we would like to delete a character which cause the inversion or inverse order, right? So we need to check if it still comes back or appears later. So I guess that's the main observation. As we notice this point, writing the code and it might be straightforward. But I would like to comment that this problem is a very important problem, and actually it can be used as a prototype problem. So starting from here, you can design or devise some other variants, right? So now with that said, let's look at the coding part. So here, basically the thing is, how could we check if a letter will come again, right, or appear again? So in this, we are going to use dictionary. So here I'm going to use the counter object. So it's a subclass of dictionary. So then we do this. So this basically counts the unique characters in S and their corresponding frequencies, right? So then we are going to do linear scan. So here let me use a stack. So it's originally empty. Then when we scan the string S, we're going to deal with the order. So basically for character in S, right? So first we want to check if we see this afterwards, so we can decrement this character by 1. So originally, if you have two occurrences of this character, it's now we seen one, right? So then we have another one left, right? So this check or this decrement basically help us to check if the same character, if we delete it, if it will still exist in the later substring, right? So then let me do this. If character in stack, so if it's already in stack, basically later we are going to join the characters in the stack. So because our goal is to contain all the distinct characters, so in this case we just continue, right? We have already done the decrement, right? And then this is the one check. Another check, it's sort of like or mimic the monotonic stack. So here basically we'll stack, because if the stack is not empty, we can do some check. So here the stack will store the corresponding characters. So actually you can store the indices, but here for this problem it's sufficient to store the character itself. If the top element in the stem still appears afterwards, because this is the character, right? So if the dictionary after this the decrement, it still has a frequency greater than 0. It means that if we even delete this stack -1, so this character, it will still appear later. So if this one and the stack top element will be larger than the current character. In other words, this will create some larger lexicographical sequence, right? So in this case, we're going to do pop operations. So we're going to do stack pop. The reason we can do the pop, because if we do the pop, we can make the string lexically smaller, and also we can satisfy the problem requirement because this condition, because this letter will appear again later. So after this, so once we exit this while loop, there are several situations. Either stack is empty, so that's the one case, or the stack is not empty, but the top element in the stack is less than or equal to the current character. However, the equal is not possible, right? Because though we do not write greater than or equal to, because we want this to unique, because this if condition. So after that, so we are going to stack append the current character. So this finished one round. So now we can actually do the return. So we are going to join the characters in the stack. So this actually forms a solution to this problem. So before we make any comments, let's first do a test. Yeah, it passes the first example. So actually, if you like, you can print out the state of the stack in the process, or print out the state of D, or you can walk through it. Now let's look at the generic case. Yeah, it passes all the cases. So here I want to point out that so the length of the S here is bounded above by 1000, which is not a large number. So in other words, in here, if we do this check, because it's bounded by 1000, and also in the stack, it contains actually at most say 26 or a double of 26, right? Because we have 26 lowercase English letters. However, if we have some other variant, if we want to do a check, we can also do something like this. We can introduce a set, right? So when we do this, so basically when we do the check, so here we can use this one. We can comment this out. So we are going to use if character in thin, right? So we're going to continue and then do this. So once we stack append this character, so we also do things add character. So this way it seems improve time complexity. Actually it does not, right? Due to the constraint here. But it's good to know you can use set to do membership check, Because set check for membership is O1 operation, and for list it's an ON, where N is the length of this list. So now with this, let's do a test also. And the answer is wrong. Let's see where is the problem. So the character, if character instant, and continue. And let's see. Oh, here we need to do remove, right? So we can use this as a temp. I can remove this temp because we have already popped that. Let's do a test. Yeah, it passes all the cases, but still, let's see. I'll copy this part, and I'm going to. So this is just for variant or revision, right? One can choose to use a set abstracted type, but here this is the problem. This is the solution for this problem. Right. So I'm going to delete this part. So and then just use this check. So we're going to have this, and then we directly do pop, and we don't need to do this, and we just use the stack, right? Yeah, with that said, I guess that's about it for this specific problem in this video. Thank you.